7.5, conditional probability and independent events. Conditional probability, we've got a formula, and that formula looks like this. Now you're going to notice a new symbol, that vertical bar right there. And that vertical bar is read as given. Okay? So it says the probability of E given F. We're finding the probability of E happening given that we know that F has already happened. And so when you see a story problem and you see the word given, that's a huge indicator that we're using this formula. Example 1, I've got a small typo, so I want you to fix this 0.07, change it to 0.2. I think I said that wrong. 0.7, we're going to change to 0.2. Okay. Otherwise, you would have gotten a negative probability or something bigger than 1, something that wouldn't have made any sense. Probability of E given F. So we see that symbol, that vertical bar, that tells us it's going to be a conditional probability problem, but we know it's just the formula. Probability of E given F equals probability of E and F divided by probability of F. Now, one thing to notice is it's always going to be on the bottom is the second thing. The second thing in the conditional, that F, that's what's going to be on the bottom. So what? We can see that the probability of E and F is 0.2. That was given to us. And the probability of F is 0.5. So reduce that. 0.2 over 0.5 reduces to 2/5 or 0.4. Problem 2. We want to know probability of A and B. So in the given information, we've got this thing right here, and we know that formula says probability of A given B equals the probability of A and B over the probability of what's on the bottom? B. It's the second one in the given statement. Okay, so that's our formula. You can rearrange that if you want to. You can rearrange that by multiplying here to say probability of A and B is equal to the probability of A given B times probability of B. You can rearrange that formula so that it's easier once you plug in, or you can plug in the numbers at the beginning. But we've got those numbers. We've got the probability of A given B is 0.5. And we've got the probability of B is 0.7. So 0.5 times 0.7 is 0.35. Number 3, 2 cards are drawn from a standard deck, one after another without replacement. That's a pretty important phrase. Find the probability that the first card is a heart and the second card is red. Okay? So probability that the first card is a heart and the second card is red. All right. So let's think about this. What is the probability that the first card is a heart? Do you know? Okay, very good. It's 13 out of 52. And we're going to multiply this times. Okay, now, so imagine, if I've got a deck of cards, I pull out a card, I show you it's a heart, okay? It's a heart, right? See it? It's a heart. Now I'm going to lay that down on the table. How many cards do I have in my hand now? 51. So I want to find the probability that the second card is red. It's going to be something out of 51, right? Good. It wouldn't be 26 because I just laid one of those red cards down on the table. It'd be 25, okay, out of 51. And so to find that probability, we're going to multiply that. You can multiply and reduce. It might be easier on your brain if you reduce first, okay? If you reduce your fractions first and then multiply, that's going to give you 1 times 25 is 25. 4 times 51 is 204. When we're talking about probabilities, you can either give reduced fractions or a decimal. As long as we know that that number is in between 0 and 1, you're pretty good. Number 4, at a local college, 4/5 of students live in a dorm. Of those who live in a dorm, 1/4 have a car. Find the probability that a student lives in a dorm and has a car. Now, I know students struggle with story problems. I think your goal should be try to make it look like it's not a story problem. So what I'm going to do is I'm going to take all of the information out of that problem and just write it down so that it looks like one of these problems, 1 and 2. These are pretty easy because you just use the formula. I want to do the same thing with this. So I go back through and I say 4/5 of the students live in a dorm. So I'm going to say probability of D for dorm is 4/5. Of those who live in a dorm, 1/4 have a car. All right. Now that's not the same thing as probability to have a car. It's probability of having a car given that we have this extra information that they live in a dorm. That's a conditional state. Probability that they have a car given that they live in a dorm is 1/4. Find the probability that the student lives in a dorm and has a car. Probability of dorm and car equals question mark. So now, this doesn't look like a story problem anymore. This just looks like a regular old use the formula problem. So you might have that formula memorized already. The probability of the conditional, C given D, equals the probability of the and statement divided by the probability of the second one. Like that. Now you might notice that I switched around C and D instead of D and C, but it doesn't really matter if you switch that around. If I switch the conditional around, that would definitely matter. But C and D is the same thing as D and C. Same thing, same thing. So I want to find the and. I should just be able to multiply these two. The probability of C and D would equal the probability of the conditional, C given D, times the probability of D for dorm. We can plug in the numbers. The probability of C given D is 1/4. The probability of living in a dorm is 4/5. You can reduce those fractions. And we get 1/5.